Continuing from the rules of differentiation, and one of the rules that we want to discuss in this video is function of a function. And what is the meaning of function of a function? When one function is inside function, we use the chain rule. Suppose y is equal to f of g of s, then dy dx is equal to dy du to multiply du dx, where u is g of x. A simple way to remember it: differentiate the outside first, then multiply by derivatives of the inside function. So let's have an example that will give us a meaningful steps. Now, example 1, we have y is equal to x plus 3 all square. So there's first function which says that u is equal to x plus 3. There is another function that says that y is equal to u square. So let's differentiate du dx. So when you differentiate x plus 3, it gives you 1. Let's differentiate dy du, it gives us 2u. There is a chain rule, and the formula for the chain rule, as we have written, you're able to see it from the board in your left side, that dy dx is equal to, and dy du is 2u, and du dx is 1, so which give us 2u. So we try to substitute the value of u, and our u is x plus 3. So we have 2 onto x plus 3. So this is example 1. So let's try to solve example 2. But in the example 2, we are going to use the simple way, which we have also been written, which is this. You won't study this. That is, you said differentiate the inside first, then multiply by derivative of the inside function. So let's solve example 2. Now, in example 2, we have y is equal to 2x minus 1. So we want to apply what is said from the beginning, that said a simple way to remember: you differentiate the outside one. You now said dy dx is equal to 3 onto 2x minus 1 squared. That is the outside one, to multiply by the derivative of the inside. And the derivative of the inside is 2x minus 1, to multiply the derivative of 2x minus 1 will give you 2. So which we have dy dx is equal to 6 onto 2x minus 1 all squared. So that is the best method so far that you make you to remember chain rule, is what we are able to practicalize. So let's also try to do another one to give us, to analyze that how we are going to remember it. You're able to see from the example 3, I said outside function and inner function. Let me try to re-explain. So if y in the example 3 is equal to 5x plus 4, all raised to power 6. So the outside function is equal to be able to write the outside function, which is 6 onto 5x plus 4 raised to power 5. We have inner function. So inner function is 5x plus 4. And the 5x plus 4, the derivative is 5. So therefore, the y, the x is equal to, so you multiply the outside function to multiply the inner function, which is 6 onto 5x plus 4 raised to power 5. Now to multiply 5, which will give you 30 onto 5x plus 4 raised to power 5. So that is the final answer for the example 3. So let me solve the example 4. So we are going to be using the outside and the inner function to solve all the remaining examples. So in example 4, we see y is equal to the square root of 3x plus 2. Now, the first thing we are going to do, you rewrite. When you rewrite, we have y is equal to we write that y is equal to 3x plus 2 all raised to power half. So let's try to differentiate. What we are going to do first, the outside one, which is this 3x plus 2 onto half minus 1 to multiply 3. So we have 3 over 2 onto 3x plus 2. By the time you subtract half minus 1 to give you minus half. So which we can still write to have 3 onto 2 3x plus 2 raised to power half. It will become positive because the minus will make it to come down. So this is just how the example 4 looks like. So let's also go to the example 5 under the function of a function. So in the example 5, we have y is equal to 1 over x plus 2 x plus 1 x plus 1. So in having this, so the first thing you must able to observe is you must rewrite, which is y is equal to x plus 1 raised to power minus 2. So in having the y, the x, we have minus 2 onto x plus 1 onto minus 2 minus 1 to multiply. The inner derivative is x plus 1. So by the time you differentiate the inner derivative, we have 1. So telling you that the y, the x is equal to minus 2 onto x plus 1 all raised to power minus 3, which will give you minus 2 all over x plus 1 all raised to power 3. So the 3 will become minus, will become plus because it has already come down. So let's see also go to we are able to solve example 5. Let's go to example 6. So in example 6, we have y is equal to s squared plus 1 all raised to power 5. You observe this, that in example 6, this is the first time we are going to have the inner derivative to have, we are able to have the inner derivative that have a constant, but this one is squared. So you said dy dx is equal to 5 onto s squared plus 1 all raised to power 4 to multiply. So inner derivative will give you 2x. So dy dx is equal to 10x onto s squared plus 1 all raised to power 4. So that is just the way it looks like. So let's go and solve example 7 and let's see how it looks like. So in example 7, which we have y is equal to 3s squared minus 5x plus 1 raised to power 7. So we said the y dx is equal to, so the outside function, which is 7 onto 3s squared minus 5x plus 1 raised to power 6 to multiply. So the derivative of inner function is 3s squared minus 5x plus 1. Well, if you have to differentiate, we have 6x minus 5. So that is answer for the derivative of inner function, which we now have 7 to multiply. Open a bracket for it. We have 6x minus 5. You close the bracket, you open another one. We have 3s squared minus 5x plus 1 all raised to power 6. You can decide the y dx. You can decide to re-expand this, which is 42x minus 35 to multiply 3s squared minus 5x plus 1 raised to power 6. So in any of this, the answer can be 7 bracket 6x minus 5. To open a bracket, to have 3s squared minus 5x plus 1. So, and at the same time, it can also be 42x minus 35. And then we close the bracket. So let's also go to the example 8 and let's see how it looks like. So in example 8, you're able to see it has a little function. Example 8 and example 9. I will only solve example 8. You use the idea to solve example 9 by yourself and you send the answer to me in the comment section. So we have y is equal to, there's a big bracket, a small bracket, 2x plus 1 raised to power 3 plus 4. You observe, you close the bracket. So therefore, you said the y dx, the most important one is outside function, which is 5 onto this the inner function 2s plus 1 raised to power 3 plus 4. You will complete it, the inner function. Now to multiply, let's continue seeing the inner function. The inner function also have an outside function, which is 3 onto 2x plus 1 all raised to power 2. Now, the inner function, you must have a bracket. Now, times 2, that is all, because 4 is a constant, which we now have 5 onto 2x plus 1 all raised to power 3 plus 4 onto, so record there is 3 outside here, there is 2, 6 onto 2x plus 1 all raised to power 2. So you have freedom to multiply 5 and 6. We have 30 onto 2x plus 1 raised to power 3 plus 4. You open a bracket, you close it, you open a bracket of 2x plus 1 all squared. So you can see expand more than this. So you use the same idea to solve example 9. And from all of this, if you see have some question to ask, you can send a question to me in the comment sections, and I will be able to do the video better than this. But we are still going to release some theoretical part of this solution in the post. So thanks for watching this video.